Okay. So we were seeing set transform in detail, and we saw how set transform becomes discrete time Fourier transform, and we tried to see what are the discrete time Fourier transform of certain signals. Uh, yeah. So today we shall see how the or what are the region of convergence for particular signals, for particular discrete time signals. Sometimes the region of convergence vary depending on the signal. If the signal is right-handed signal, particular region of convergence will be included. If it is left-handed, it may be excluded. Something like that will be there. So we shall see in detail how this region of convergence is dependent on the characteristic of the signal xn. Particularly what happened when xn is right-sided signal, left-sided signal, if it contains both left-sided and right-sided, etc. Okay. So now let us use of the board we have. So we shall move to the board now. Okay. Now suppose that you have a signal, say xn, which is say right-sided signal like this: 0, 1, 2, 3, 4. These are right-sided signal. 1, 1, 2, 1, etc. And in this kind of signals, uh, which are positive, which have values only on the positive side, what will be the xz? Xz will be sigma n xn z raised to minus n. In these cases, n takes only positive values. So in z raised to minus n, n takes positive values only. So suppose z goes to say infinity.
സാർ
Yeah, you can tell.
അമലിന് കയറാൻ പറ്റുന്നില്ല എന്ന് പറഞ്ഞു.
Amal would have been removed when the recording started. He can enter again.
ആണോ? അല്ല, റെക്കോർഡിംഗ് സ്റ്റാർട്ട് ചെയ്തിട്ടാണ് തോന്നുന്നു. അവൻ റിക്വസ്റ്റ് കൊടുത്തിട്ട് ആക്സെപ്റ്റ് ചെയ്തില്ല എന്ന് പറഞ്ഞു.
Yeah, I think Amal is inside.
അമൽ സിറിയാക്കല്ല, അമൽ കൃഷ്ണ.
Yeah, now he's inside. Okay. So as z tends to infinity, what happened? As z tends to infinity, this become z raised to minus n become. Okay, somebody is entering. What happened when z tends to infinity? N take positive value and z tending to infinity. N is having only positive values. Then if z tends to infinity, what happened? Can anyone of you tell? You can unmute and tell so that everyone can hear. If you chat, if you type chat, I will be able to see, I think. What happens when z tends to infinity? When n takes values from to infinity. Can you tell? Please make sure that you enter inside earlier. Yeah. So can you tell what happened when set tends to infinity? You can type or unmute and tell. Set transform tends to 0. I think Ashwin is telling this. Yeah. So why do set transpose tends to 0? Set raised to minus is 1 by set raised to n. As set tends to infinity and n takes positive value, suppose n tends to infinity also, then set raised to n will tend to infinity and 1 by set raised to n will tend to 0. So this will tend to 0 and this can easily converge. Okay. So set equal to infinity or set tending to infinity will always be inside the ROC, or ROC will contain set tends to infinity. Now in this case, what happened when set tends to say 0 value? Set tends to very small value. What happened? What happened to set raised to minus n? When set tends to 0, what happened to set raised to minus n? 1 by, you have 1 by set raised to n, and when set tends to 0 value, very small value, this is going to be very small and this tends to infinity, and the whole thing tends to infinity, and hence this will not converge. So set equal to 0 will not be included in the region of convergence. So what you understand from this is that for a right-handed signal, as you have seen, for z equal to 0 it doesn't converge, and z equal to 0 is not at all included in the ROC, but z equal to infinity is always included. So suppose that this kind of right-sided signal have some value. Okay, 1 minute. Okay, suppose that we can draw the ROC as so if suppose this has some poles, say z by z minus 3 by z minus 2. Suppose this is a set transform of the signal, and suppose you have a region of convergence mod z greater than 3 or whatever it is. Z equal to 0 is never inside the ROC. This is never inside the ROC. So suppose that z equal to, suppose that mod z equal to 4 is the circle. Everything outside the circle can be ROC, including z equal to infinity. So z equal to 0 will not be there, and if you have some areas in between two poles, if that is ROC, that can be included. But remember, z equal to 0 can never be included in this kind of right-handed signal. Now let us consider left-handed signal. Suppose the signal is left-handed. Then how is the signal? Suppose you have a left-handed signal. -1, -2, -3, etc. You have values. Okay. Suppose this is left-handed signal. So 1, 2, 1. This kind of signal, if you take set transform xn z raised to minus n, for left-handed signal, what will happen? Your n values are all negative. So 1 by z raised to n, if you take 1 by, or suppose you have negative values of n, and n is all having negative values, z raised to minus n, if you consider set or set tending to 0, z raised to minus n, as n are negative, as n tends to 0, this will tend to 0 and will converge. And as z tends to infinity, this become 1 by z raised to infinity. Oh, sorry, 1 by z raised to n. And as z tends to infinity. Am I audible to all of you? Am I audible, and is the board and all clear? Can you just type something? Okay, fine, fine, thank you. So as z tends to infinity, you can see that, say here, you have z raised to minus n on 1 by z raised to n as z tends to infinity, and n takes negative values. What happened to this z raised to n? This will become very small value because as z tends to infinity, and 1 by z raised to n become very large. So now you can see that. So what do you understand from this? The reverse thing happens here. That is, for z equal to, for z tending to 0, it will converge, while z tending to infinity, it won't converge. So when you have left-sided signals like this, which have only left-sided value, these are not causal signals. Causal signals have values only on the right-hand side. Why do you call it as causal signal? Because if you consider Hn, you consider Hn, which is the impulse response, and if you have impulse response on the positive side, you call that system as causal system. If you have impulse Hn on the negative side also, you call it non-causal system. This is in terms of impulse response. You can define it in terms of your system representation as yn equal to xn minus 1 plus 3xn minus 1, etc. In that, from that also you can find a system is causal or not. So now you understood what happens when you have signals, when you have signals which are right-sided signal and left-sided signal. Okay. Now coming to, okay, we shall use the other side. Maybe this is better for you. So now coming to the signals which are both sided, say some are having on the left side and some on the right side, say from minus n1 to plus n2. So these are minus 1, minus 2, etc. up to minus n1, 1, 2, 3, etc. up to n2. So this is a two-sided signal. And if you consider the set transform of this sigma xn z raised to minus n vary from 0 to infinity. When you give n values to n, say from minus n1 to n2, you have values on the negative side as well as right side. What happens when z tends to infinity? When z tends to infinity, 1 by z raised to n will tends to, as z tends to infinity, 1 by z raised to n will tends to infinity for n positive values. So if n takes positive values, this will tends to infinity and hence will not converge. Similarly, suppose set takes 0 value, set tends to 0, this will tends to infinity for negative values of n. If n take negative value, minus n will be positive value. So set raised to n will be, what happened? You have, when you have set tending to 0, what happened to this? This normally, this is 1 by set raised to n. Okay. So for positive values of n, this will tend to infinity and hence will not converge. So for z equal to 0 and z equal to infinity also, for both these values, these kind of two-sided signals will not converge. So ROC will never include z equal to 0 as well as z equal to infinity in these cases. So when you have a set plane, this is not included in the ROC. So this will not be there in the ROC. Similarly, z equal to infinity will also not be in the ROC. And suppose the set transform of this, or the system response transfer function, suppose it is z minus 2 into z minus 3, something like that. And suppose that your ROC is 2 less than mod z less than 3, then it, this is z equal to 2 circle of radius 2, z equal to 3 circle of radius 3, and ROC is in between 2 and 3. It will never include, okay, somebody is entering. It will never include z equal to 0 as well as z equal to infinity. I hope it is clear to you. Okay. Is there any doubt? If you have any doubt, you can ask. You can unmute and ask. I can answer you. Is there any doubt? Okay. Now, so now we came to know that different signals having, whether they are depending on whether they are left-sided or right-sided, some part of the set plane may be included or may not be included, right? So by that way, if ROC is to be fine for some signals, you have to consider all these things while determining the ROC. Okay. So now let us see periodicity of certain signals. For example, suppose you have some signals like say sine pi by 3 plus sine pi by 5, or yeah, sine pi by 3 plus sine pi by 5. Is it a periodic signal or a aperiodic signal? If I have a signal sine pi by 3 plus sine pi by 5, can you tell whether it is periodic or aperiodic? You can unmute and tell. I want to hear from you. Sine pi by 3. Okay, what about sine pi by 3? You take a signal sine pi by 3. Is it periodic or aperiodic? Anyone can unmute and tell. Don't type, you can just unmute and tell. Sine pi by 3, is it periodic or aperiodic?
Aperiodic.
It is aperiodic. Who told her?
Ashwin.
Ashwin. Okay. Ashwin, can you tell why it is aperiodic?
Sine pi by 3 has the same value regardless of what a value of n is, right?
Okay. So that is a periodic signal, or it is a constant value, right? So let us now consider sine n pi by 3. Is it a periodic signal or a periodic signal? Or sine pi t by 3. Let's consider sine pi t by 3. Is it periodic signal or a periodic signal? Anyone can answer by unmuting the mic. Sine pi t by 3. Is it periodic or aperiodic? See, I want sessions to be interactive. Sine pi t by 3. Is it periodic or aperiodic?
This is periodic.
It is periodic. Okay. Why is it periodic? What is the period?
Period. Six.
Period is 6. See, sine pi t by 3 means you can write it as sine 2 pi t by sine pi t by 3 means you can write it as sine 2 pi t by 6, which is having a period of capital T equal to 6, right? So now can you tell whether a signal represented like this, sine pi t by 3 plus sine pi t by 5, is it periodic or aperiodic? Sine pi t by 3 plus sine pi t by 5. Is it periodic or aperiodic? Okay, Anju is telling periodic. Anju, can you tell why it is periodic? And what could be the period for that? Anju TA, is she here?
Sir,
Yeah,
sir,
yeah.
sir, both are 6 and 10. So the ratio
Can you be
given
a
by
little
P2 will
louder?
give a rational number.
I'm not hearing you.
Sir, sine pi t by 3 has a period and sine pi t by 10 has a period of, sorry, pi t.
I think the audio is not clear. Can you just type? I'll read it out. Yeah. Okay. So yeah, I got many answers. So basically, when you have say pi t by 3 and okay, let us see the board. When you have sine pi t by 3 plus sine pi t by 5, you can represent it as sine 2 pi t by 6 plus sine 2 pi t by 10. That means these are two sine waves of period 6 and 10 seconds each. So if you try to plot it, you try to plot these signals. One signal is say up to 6 duration. 6 second, starts from here and ends here. Another is up to 10 second, starts from here and ends here. Magnitudes are same. Magnitude from say -1 to 1, -1 to 1. This also -1 to 1. So in these cases, this is a periodic signal. If you add them together, you will get another signal that may be something like this, whatever it is. If you have long, many multiple cycles of these kind of signals, if you add them, probably the signal that you get is something like this, which gets repeated. And where will be the period of the new signal? When you add them together, this is one cycle of this is another cycle of this, and this will, the end point of these cycles, a finite number of cycles of this wave and finite number of these cycles will coincide at some point. Can you tell where it will coincide? After how many cycles of this wave will it coincide with the endpoint of this? That means endpoints of these two coincides at how much seconds? What time will they coincide? Can you tell? How many cycles it may take? This will take 5 cycles. If you go 5 cycles, it will go reach 30 seconds. 6 seconds, this is 6 seconds. If you have 5 such cycles, you will have 30 cycles. At the end, it will stop at the 30 second. Similarly, here you have 10 second. If you have 3 such cycles, it will also end exactly at 30 second. So they will end exactly at 30 second, and hence the period of this waveform, when they add it together, the new waveform will have a period of 30 second. So when you have 6 second and 10 second waveform, periodic waveform with period 6 and 10, then the LCM of 6 and 10, which is 30, right, is the period of the signal. Is that clear? Is that clear to all of you? Okay. Yeah, I think it is clear to you. Now, let us consider, I think, what is the time now? It is, our time is over. Time, yeah, we have 5 more minutes, right?
Sir,
Yeah, 5
5
more
minutes
minutes.
കൂടി ഉണ്ട്.
Okay. Okay. Now, we shall see one more signal. Say sine n pi. Consider a signal sine n pi, which is a discrete time signal. If you have a signal sine n pi, can you tell whether it is discrete or? I'll write the sine n pi signal. Sine n pi is something like this. Sine n pi. I have a signal sine n pi. Is it periodic or aperiodic? That's the question. Will the signal be periodic or aperiodic? You can type whether it is periodic or aperiodic. Okay, what do you mean by period? What do you mean by a periodic signal? Okay, periodic with period 2. Okay, sine n pi. It is periodic with period 2. Okay, any other answers? Let's try to plot this. Let's try to give values for n. Say n equal to 0, 1, 2, 3, etc. Let's call this x. So x will take value sine 0 pi is 0, sine pi is 0, sine 2 pi is again 0, sine 3 pi is 0, sine 4 pi, all these are 0. All these value take 0 values, right? So this is a 0 signal, so you can call it either periodic or aperiodic. So now let us take sine pi by n. Is it a periodic signal or aperiodic signal? And let us consider another signal also, sine n pi by 3. What can you tell about these two signals? Sine pi by n and sine n pi by 3. Is the first signal periodic? Is the first signal periodic? First signal is, okay, Ashwin is telling that first signal is periodic. Ashwin, can you explain why it is periodic? Yeah.
No.
No,
Sine
it
n
is
pi,
sine
right?
pi by n.
Oh, pi by n.
Pi by n is not periodic.
Pi by n is not.
Huh?
Pi by n.
Okay, anyone can answer sine pi by n or sine n pi by 3, whether they are periodic or aperiodic. Can unmute and tell. Sine pi by n, if you give different values of n, what you get is sine pi by 1, sine pi by 2, sine pi by 3, sine pi by 4, sine pi by 5, etc. And these values, it doesn't repeat anyway. So it cannot be a periodic waveform. They have to repeat, and the repeating, when it start repeating, becomes the period of the signal. And what about sine n pi by 3? Sine n pi by 3, you give different values to n. Sine, if you give n equal to 0, 1, 2, 3, etc., it becomes sine pi by 3, then sine 2 pi by 3, sine 3 pi by 3, sine 4 pi by 3, 5 pi by 3, etc. And you can see whether it is periodic or not. Okay. So like that, for discrete signal and for continuous signal, you can see whether the signal is periodic or aperiodic. Similar to that, if you have sine pi by n plus sine pi by 3n plus signals which are summation of different signals, then you can find whether the signal is periodic or aperiodic there also. Okay. So I think now the time is almost up. This I have uploaded, and I will upload in YouTube and give a link to the in Moodle. I think the previous class recording, I gave it as a link to the Google Drive. that I think many of you couldn't access. So I'll upload that also in Moodle and give a link it in Moodle, right? So I think we shall stop now. Next class we shall have next day. So thank you all of you. Is there any specific comments or discussions required? Otherwise, thank you. You can leave the meeting and join the next class. Yeah, thank you. Thank you all of you.